Okay, well, thank you very much for joining. My name is Eddie Thompson, and I am the lead solution engineer for Sumo Logic in APAC ANZ, coming to you this evening or this afternoon from Melbourne, Australia. So thank you very much for joining, and I hope you find a bit of interest today, and I'm going to talk to you about software development optimization and how we can help you with that here at Sumo. So for those of you who aren't overly familiar with Sumo, I'll just cover off some of the basics. So one of the important things that we do here is allow you to have multiple teams and multiple use cases using the platform. So we like to say that we're a machine data analytics platform and we're democratizing access to machine data. So you've got some different teams who've got some different use cases and things they're trying to achieve as far as their observability is concerned. So you've got people like your DevOps engineers and your site reliability engineers, and they're looking to improve things like their mean time to identify and their mean time to resolve. They're looking to monitor and detect unknown issues. They're looking to diagnose services which might be causing downtimes and identify and fix root causes and restore their app performance. And then you've got software engineering, and they're the sort of people who are likely interested in what I'm talking about today. They want to improve their software quality and the velocity of their software delivery. So they're going to be monitoring things like their CI/CD pipeline. They want to diagnose where they've got process problems, where they've got inefficiencies in their processes, where they've got failures in their pipelines. And they want to be able to determine those root causes of process issues and optimize those pipelines. And finally, you've got the security side of observability. So this is where we get into the DevSecOps, and they're looking to protect customer data. They're looking to be able to correlate and detect across their various streams of information and look for threats and vulnerabilities. They're looking to identify sources of vulnerability and particular attack vectors within their systems, and they're looking to sort of understand the impact of what's going on in their environment, blast radiuses, and how they can remediate problems when they occur. So what do we mean when we talk about software development optimization? So it's changed a lot in the last few years. So there are now a huge variety of options in tooling when it comes to the software development ecosystem. It's not just someone writing some code and then every now and again there's a release. You've got CI/CD tools, you've got development tools, you've got containerization, you've got a bunch of cloud tools that go along with it, you've got vulnerability management tools, you've got performance management tools. There's so many different things, and these are all producing loads of data. And what we help do here is give you a place to put that data, whether that be structured data, whether that be unstructured data. That could be issues from Jira, that could be webhooks that are generated when you check something into GitHub. It could be a deployment event from Jenkins. These are all available to be pulled into Sumo, and we basically are able to enrich this data, normalize it to a common schema, and then allow you to sort of correlate across these various sources and get some intelligence out of that data and basically give you that sense of observability into your software development process. And the question is always, why do we want to do that? What are the benefits? And what we find is that teams are looking at faster release velocities, improved reliability and security, and basically also enabling greater collaboration across their various development teams. So we're really looking at giving you end-to-end visibility across your full software development lifecycle. And as that works across sort of plan and manage, develop and build, test, release, deploy, run. And this is all sort of providing feedback loops into your sort of continuous improvement, continuous deployment lifecycle. And how are we sort of monitoring these particular benchmarks? We're doing this based on the DORA metric. So if you're not familiar with DORA, that is DevOps Research and Assessment. Done a lot of different surveys and investigation over the years into development and DevOps groups, and basically how people are writing and deploying software, who's doing it well, who can improve what they're doing. And they came out with these particular metrics, the key DORA metrics, which I'll touch on a little bit further, but deployment frequency, lead time for changes, mean time to recovery, and change failure rate are all affected by these metrics. Now, the important thing is that we're not just like grabbing some metrics and visualizing them. Because we have these logs and events in their full form across your entire DevOps lifecycle, even though we're normalizing them and exposing them in a common format, the raw events are still there. So when you actually need to dig into a particular event, you have all the data. You're not just dealing with the rolled up metrics. You have that underlying data for investigation and drilling down where you need to. The fact that we enrich this data is also really important, because it means that although you might have the rolled up metrics for your development organization, it means you can also filter down to a particular repo or team or service or product, and really sort of find out how these specific parts of your business or your organization are contributing to the whole. And the other thing that's important here is this is extensible. So there's a lot of business logic that goes into how you make some of these decisions, and what makes sense for some organizations doesn't make sense to others. And the fact that this is all able to be modified, it's easily done by the end users. It's written in the Sumo query language. So it's something that can be very easily modified to your specific use cases. If you need to add additional tags and filters, you can absolutely do that. So a little bit of an architectural overview here. The important thing about this is that Sumo is a data platform for pulling all this data in. And a lot of the times you've got multiple sources of data for this across various tools, across various teams, and a lot of it may already be in Sumo. So it can be a very low cost uplift to get the complete set of data and derive a lot of additional value from that data you have in your environment. If you don't have this data already in there, we've able to set this up in minutes. We give you a Terraform script, and that'll automatically configure both the Sumo side and the tooling side for things like Jira, GitHub, OpsGenie, PagerDuty, Jenkins. Populate all the particular webhooks, create the automated issues and alerts, deploy all the dashboards, normalize everything to a schema, and have it all there up and running very quickly. And I talked a little bit before previously about why would you do this, and the simple fact of the matter is high-performing software delivery teams win. So compared to low-performing software delivery teams, and the DORA metrics sort of define these across elite, I can't remember what the middle one is, but elite, someone in the middle, and low. And basically, the highest performers deploy code much more frequently. They have a much faster lead time from commit to deploy. They are extremely many times faster at recovering from incidents, and they have far fewer deployments of breaking changes to their environment. So as I mentioned before, we can sort of break out these DORA metrics, which we're tracking, being deployment frequency, lead time for changes, mean time to recovery from failure, and change failure rate, into two broad categories. The first being measures of agility. So how often is your code deployed to production, and how long does it take you to merge from a merge of a commit to deployment in production? And then the other side is reliability. So how long does it take you to recover from production incidents? And of your deployments, what are the percentage that subsequently require remediation? So I don't want to bore you to death with slides, so let's do it live. We'll jump into a demo and have a look at what this looks like in the Sumo platform. So what I have here is a Sumo dashboard looking at my DORA metrics overview. And the important thing to notice is that this is a live computation as it's running. So every time I load up this dashboard, I'm getting up to the minute information. This isn't something that my Scrum leads need to cook up for me at the end of the month. I've got this going on, and I can check on what's going on and see up to the minute information. And it gives me things like, my deployment frequency, and we're automatically color coding these based on these benchmarks which have been established by DORA. So this isn't something that Sumo's cooked up. We're using industry standard bench time here, so I can see what my deployment frequency per week is. I can see the trending analysis over time, my change failure rate, my time to restore service, and my lead time for changes. And I can see here my lead time for changes is in yellow, so that's not great. And I can also see that it's trending upward. And generally that's the sort of thing I'd much rather it was trending down. So I can dig into that a bit more to see what is actually going on there. So I can click into my lead time dashboard, and that's where I can sort of drill into what's going on. Now, as I mentioned, this is extensible and filterable. So I've got my filters up the top here, and I can do things like filter it down to only show me my production or staging environment or pre-pod. If I want to look at a particular team or a particular repo, I could filter that down as well. But running left to right, I've got my lead time. I can see my repos, which have the slowest lead time in their distribution, breaking it out by service, by team, and importantly here, by pipeline. And so this is where I can see my average pipelines in duration, and my master build test pipeline is running much, much longer. So 26 hours versus 2 for my master deploy. So there's definitely something that's a problem there. So I can actually go, right, let's investigate what's going on within a pipeline. So we've got a pipeline stage monitoring dashboard. So this is where I can sort of see my pipeline executions, where they're happening, particular stages which have failed, and pipeline duration. And this allows me visually to see the particular stages within my pipelines that may be a problem. So I can see here master build test, and the lion's share of this is being taken by my regression tests. So I can actually filter this down specifically. So I can say my pipeline, master build test, and if I wanted to filter it for regression tests, so now I'm actually filtering down dynamically because I've got the full underlying data set. And now I can see sort of what's going on. So where are my actual slower steps within those stages? Okay, so regression tests, run backend ETL tests. So I've been able to go from a overview, letting me know that there's a problem with one of my key metrics, investigate where I may be having a problem in that lead time metric, investigate the particular pipeline, identify a problem stage, and then even down to the level of a particular step. So that means that I can say, hey, whoever's responsible for this deployment pipeline, you need to check out the run backend ETL tests and find out why this is taking so long, because it's blowing out our pipeline times. But this is what's important about having that full set of data available to you, because you can go from that high-level metric down to the really specific level of detail when you do identify a problem. So what's really cool about that is, that's that high-level overview to the high-level specificity is great, and that's looking at things in the deployment pipeline. But we're also providing you a lot of other information. So being able to investigate things like pull requests is a really, really powerful part of this product. So people spend a lot of time trying to optimize their pipelines and really sort of wring extra sort of seconds and milliseconds out of their build chain and their deployment chain, and how long these sort of things take. But then they might look at their pull requests here and find that, oh wow, we're burning a lot of time by how long it takes our PRs to get reviewed and the average time to close here. And this is where you can really identify some of these human procedural problems in your organization that you need to fix. So what is my distribution of PRs by service, by target branch? Who are my top reviewers? Which reviewers have the longest average time to close? Which repos have the longest average time to close? These are the sort of things where you can go, okay, here's some teams which are doing it really well. We need to have a look at what they're doing and really sort of bed down their process for the other people. Or these repos have huge average time to close. Maybe we need to train up some more people to be able to do the reviews on these particular repos, because it's blowing out our time. And that's one of those places where you can easily gain a lot of hours rather than chasing minutes and seconds in your pipeline optimization. And just being able to see what's happening with your trending over time is really great. What else we've got here that I really particularly like is being able to see your pull requests by time to merge, where your last sort of summary PRs are coming from. And it's not just for PRs, you can also do these for things like builds. So once again, able to filter down by your repo service team. Where are your builds happening from? Which teams and which services are having loads, which are having not so much? How are your successes and failures tracking? Are you seeing one spike in relation to the other? And this is just a really great thing too. So where are my most recent failed builds and my most recent successful builds? And when I do see a failed build, it gives me a link right into the specific issue in GitHub. So these deep link in directly, and so it's easy to sort of jump out and see if you want to dig into the issue. And finally, jumping over to the alert side of things. So this is where we're starting to track back towards things like time to restore service and your change failure rate. So alerts are related to these. Now, whether you've got your alerts going out to Slack, or whether you're tracking them in OpsGenie or ServiceNow, PagerDuty, you can pull all that data into Sumo and showing you things like what's your distribution of alerts, which services are having the most alerts, which teams, what are my ratios of created versus closed, where am I seeing my high priority alerts from which particular services, all this information, because once again, it's being pulled out from your specific underlying data. So if I wanted to jump out to PagerDuty for a specific alert, I can as well. The last thing I wanted to show you was the pipeline overview dashboard. And this is a really powerful one because this gives you a sort of right to left view of what's going on with your development pipeline. So what are my pipeline execution trends across my various pipelines here? I can see both of those tracking together. Where have my alerts come from my last from my critical services, my last 10 critical alerts, my last 10 failed deploys, my last 10 failed builds, and my top 10 pull requests by time to close in hours. So this is allowing me to sort of track back across problem areas across my organization and sort of quickly drill into things that may be an issue. Last 10 critical issues being pulled out of Jira and the trend of where I've got my issues, what are complete, what are done, what are to do, and where are my issues that took the longest to close. Am I seeing particular projects where I'm having an outsized number of issues compared to everyone else? So that's one of those things that, yeah, really, really important to drill down into. The fact that you do have that consistency of availability of data and the ability to drill into what's happening and determine in real time how you can sort of better improve the software that you're putting to market. So what we do here is we make it really easy for you to benchmark and optimize your software development and delivery performance across the entire DevOps lifecycle. So with this software development optimization solution, we can help you release code faster, improve your application reliability, and increase collaboration across your various development teams. And this is in the same platform that you can do your monitoring and alerting, do your investigations, do your security. It's a lot of value to gain with not a lot of extra data to ingest. So if you're already using Sumo, I highly recommend checking it out. Really easy to get up and running. If you're not a Sumo customer, please jump onto sumologic.com, spin up a free trial. You can get this up and running and get some real insight into what's going into your development organization. So I want to thank you very much for your time. Once again, my name was Eddie Thompson, and I hope you found this interesting.